Today's lesson is 7-1, Multiplication Properties of Exponents. Definition of a monomial. A monomial is a number, a variable, or the product of a number and variables with non-negative exponents. In a monomial, there will be no addition or subtraction, and there will be no variables in the denominator. Okay, I have a really corny joke. What a monomial really is when your mother doesn't cook dinner. Ma-no-meal. Mom didn't cook dinner? Okay, sorry. Let's move on. Okay, so first examples here. Determine whether each expression is a monomial and explain. So 16x squared y. Yes, that is a monomial because it's only the product of numbers and variables. Product means multiplication. That's just 16 times x times y. Second example, 7 divided by a squared. That is not a monomial because it has a variable in the denominator. Remember, a monomial does not have any variables in the denominator. Number 3, 3x plus 5y. This is actually the sum of two monomials. 3x is a monomial, 5y is a monomial, but remember, a monomial has no addition or subtraction. So this is not a monomial because it has addition. Negative 6. Yes, that is a monomial because it's just a number. Remember, the definition of a monomial is a number or a variable, or the product of a number and variables. And number 5, x. Yes, x is considered a monomial because it's a variable. Okay, several properties here that we're going to go through. First one is called the product of powers. And by a power we mean a base raised to, with an exponent, raised to a particular power. So to multiply two powers that have the same base, add their exponents. In this case, a is the base. I like to call it the big number on the bottom. That makes it the base. And it's a to the m. A raised to the power of m is a power because it's a base with an exponent. So a raised to the power of m times a raised to the power of n is a raised to the power of m plus n. So if you're multiplying two powers that have the same base, you add their exponents. Here's an example. X squared, x to the 2 times x to the 4 is x to the 2 plus 4, or x to the 6th. Memorize that property. Let's simplify each one of these. The quantity 3x to the 5th times 2x squared. I want to multiply my two coefficients, my two numbers out front. That gives me 6. And then since x to the 5th is a power and x squared is a power, they have the same base, which is x. I'm going to add their exponents. That would be 6x to the 7th. Number 2, 2a squared b cubed c to the 5th times negative 8ab to the 4th c to the 3rd. I'm going to start by multiplying the exponents. Multiplying the coefficients. That gives me negative 16. And then I'm going to look at my a's. I have a squared times a. That's like a to the 1. So a to the 2 times a to the 1 is a to the 3. b cubed times b to the 4th, b to the 3 plus 4, or b to the 7th. And c to the 5th times c to the 3rd is c to the 5 plus 3, or c to the 8th. So remember, multiply your coefficients, and when the bases are the same, add the exponents. Here's another property. A power of a power. In order to raise a power to a power, this is when you want to multiply the exponents. So a to the m is a power, and we are raising it to the nth power. So a to the m raised to the n is a to the m times n. Or here's an example. X to the 5th, the whole thing raised to the 3rd power, is x to the 5 times 3, or x to the 15th. Let's take a look at a couple examples here. Number 1, y to the 6th cubed. That's going to be the same as, and basically remember what that means is it's y to the 6th times y to the 6th times y to the 6th. So 3y to the 6ths multiplied times each other. And that's going to give you y to the 6 times 3, or y to the 18th. This one's a little more confusing. 2 to the 3rd raised to the 4th squared. Let's kind of start on the inside and work out. So let's just focus on 2 to the 3rd. And actually, I don't want you to turn 2 to the 3rd into a real number. We're going to leave the base as 2. So 2 to the 3rd raised to the 4th power is going to be 2 to the 12th power. 3 times 4 is 12. And that whole thing is squared. And 2 to the 12th squared is 2 to the 24th power. Like I said, don't plug that into your calculator. I don't want to know what 2 times itself 24 times is. What I'm checking to see is, do you know how to deal with this property, a power of a power? And one more product, or one more property. The power of a product. To find the power of a product, in other words, we have two things multiplied and it's raised to the power. Find the power of each factor, then multiply. So the quantity AB raised to the power of m is the same thing as a to the m times b to the m. You can break up, AB is the product of a times b, and you can break those up. Here's an example. 3x squared y, all raised to the 3rd power. This 3 exponent out here applies to the 3 coefficient, it applies to x squared, and it applies to y. So I can rewrite this as 3 cubed times x squared cubed times y cubed. 3 cubed is 27, x squared cubed is x to the 6th, and y cubed is y cubed. Let's take a look at a couple examples. 6xy squared, the whole thing squared. Now, the mistake people often make is they think, okay, I've got an exponent inside the parentheses, an exponent outside the parentheses, so I can multiply. That's fine with the exponents, but you do not multiply this 2 outside times the big 6. What this really means is 6 squared times x squared times y squared squared. Don't give me a 12 for your coefficient. It's actually going to be 36. The squared applies to the 6. 6 squared is 36. X squared, y to the 4th. To solve this one, what I'm going to do is I'm going to deal with the negative 3x squared y z cubed all squared. And I'm going to simplify that. And then I'll do 2x to the 4th, z to the 5th all cubed. And another, kind of simplify just that. And then I'll multiply the 2. So, negative 3 squared is 9, because negative 3 times negative 3 is 9. X squared squared is x to the 4th. Y to the 1 squared is y squared. And z to the 3rd squared is z to the 6th. Next part of the problem. 2 to the 3rd power is 8. X to the 3rd power is x cubed. Y to the 4th to the 3rd power is y to the 12th, and z to the 5th raised to the 3rd power is z to the 15th. Now I need to multiply these two, so I will multiply the coefficients. 8 times 9 is 72, and then for my x's, I will add the exponents, which gives me x to the 7th. For the y's, I'll add the exponents, y to the 14th. And for the z's, I will add the exponents. Z to the 21 power. That's huge. That's my final answer. And just to sum up, you know an expression is simplified if each base appears only once. In other words, in your problem, there is only one x, or one y, or one z. The base cannot appear more than one time in the whole expression. There are no powers of powers. There's no parentheses, exponent inside the parentheses, exponent outside the parentheses. You're getting rid of the parentheses. And all your fractions are simplified. I don't want to see 6 over 8. I need to see 3 over 4.